Welcome to the video guide for the FlashyScience Ohm's Law experiment. On the screen you'll see two digital multimeters or DMMs, a power supply for applying potential difference to resistors, and a resistor. The value of resistance of the resistor is indicated by the coloured bands that it has. Now we can change these simply by clicking on the resistor and moving to a new screen where we can choose the colours of the various bands. Click on the band you wish to change and it will start to flash. Then choose from the colours that are available on the colour palette. There we are. The first band is now red. Now the first three bands code for the central value of resistance, and the fourth band codes for the tolerance of the actual value of resistance compared to the central value given by the first three. So for instance, the colour code here of red, black, red means 2000 ohms or 2 kilo ohms, and the gold colour of the fourth band means a tolerance of 5%. This means that the resistor will have a value of resistance within 5% of 2000 ohms. 5% of 2000 ohms is 100 ohms, which means that the resistance will be between 1900 and 2100 ohms. If you're not sure why this is, then see the FlashyScience instructions that are associated with this experiment, or you'll find it through a quick web search or in many labs. You can check your understanding of resistors you select using the menu system from the main screen, which I'll describe in a moment. Once you've chosen your band colours, click on the green and white confirm button to return to the main experiment with the new resistor in place, like so. Use the right-hand DMM to measure the resistance of the resistor directly. First, click and drag the DMM's dial until it is on the Ohms symbol, which is for measuring resistance. Then click on one of the crocodile clips on wires connected to the DMM. The wires on either side of the resistor will now be flashing. These show locations where the crocodile clips can be placed. Click on one of these flashing wires to position the clicked crocodile clip there. Then click and place the other crocodile clip on the other side of the resistor. You'll then see the measurement of the resistance in the DMM screen. This is 1.95 kilo ohms, which is different from the central value coded for by the first three coloured bands, but is within the limits of tolerance given by the fourth band. We can also apply potential difference to the resistor and measure the current flowing through it. To apply a potential difference, turn on the power supply by clicking the power button, and then click and drag the dial to increase the potential difference. The value of potential difference in volts applied to the resistor is shown on the power supply screen. We can also measure the potential difference with the right-hand DMM by clicking and dragging the dial until it is on DC volts. You can see that in this case, with a single resistor, the value on the DMM screen matches that on the power supply screen. The left-hand DMM can be used to measure current. This requires a different arrangement of connections which this DMM has. Click and drag the dial on this DMM until it is on DC current, which is shown by the letter A with a full and dashed line above. You'll then see the current flowing through the resistor on the screen of the left-hand DMM, and the potential difference to the resistor on the right-hand DMM. These can be used to calculate the resistance of the resistor using Ohm's law. Ohm's law also means that the potential difference and current through a fixed resistor are proportional, and this experiment allows you to explore that. The experiment also has functionality that you can access via this icon in the top left of the screen. This opens a menu with 5 more icons. The first icon simply closes the menu again. The second icon returns you to the experiment when you are on a question screen. We'll come to those shortly. The third is the Click Information icon. Selecting this will highlight all of the areas on the screen that can be clicked to control the experiment. The fourth icon opens up a screen of questions directly related to the experiments you might have just performed. The final icon opens up revision questions that cover the area of Ohm's law more generally. All questions are answered automatically, and many contain randomly generated numbers, so you can retake them as many times as you like for practice. We very much hope you enjoy using this FlashyScience Ohm's Law experiment.